Applications of stepper motor. Introduction. A stepper motor is an electromechanical device which converts electrical pulses into discrete mechanical movements. The shaft or spindle of a stepper motor rotates in discrete step increments when electrical command pulses are applied to it in a proper sequence. The motors rotate have several direct relationships to these applied input pulses. The sequence of the applied pulses is directly related to the direction of motion shaft rotators. The speed of the motor shafts rotating is directly related to the frequency of the input pulses, and the length of the rotation is directly related to the number of inputs of pulses applied. Stepper motor. A stepper motor uses a theory of operation for magnets to make the motor shaft turn a precise distance when a pulse of electricity is provided. The stator has 8 poles and the rotor has 6 poles. The rotor will require 24 pulses of electricity to move the 24 steps to make one complete revolution. Another way to say that is the rotor will precisely 15 degrees for each pulse of electricity that the motor receives. Stepper motor. Construction of stepper motor. In this motor, the stator is of multipolar and its construction is similar to that of variable reluctance stepper motor as discussed above. It consists of slatted periphery on which stator coils are wound. It has projected poles on the slotted structure where the wound windings can be 2 or 3 or 4 phase. The end terminals of all these windings are brought out and connected to the DC accelerated via solid state switches in the driver circuit. The rotor is made up of permanent magnet materials like ferrite. Construction of stepper motor consists of coil, stator, shaft, ball bearings, rotor, magnet and flame. Stepper motor types. There are 3 types of stepper motor. They are permanent magnet stepper motor, hybrid synchronous stepper motor, variable reluctance stepper motor. Advantages. The rotation angle of the motor is proportional to the input pulse. The motor has full torque at standstill. Precise positioning and repeatability of movement, since good stepper motor have an accuracy of 3 to 5% of a step, and this error is not cumulative from one step to the next. Excellent response to starting, stopping and reversing. Advantages. Very reliable since there are no contact brushes in the motor. Therefore, the life of motor is simply dependent on the life of bearing. The motor response to digital input pulses provides open loop control, making the motor simpler and less costly to control. It is possible to achieve very low speed synchronous rotation with a load that is directly coupled to the shaft. A wide range of rotation speeds can be realized as the speed is proportional to the frequency of the input pulses. Disadvantages. Resonances can occur if not properly controlled. Not easy to operate at extremely high speeds. Applications of stepper motor. Applications in industrial machines. Stepper motor are used in automotive cases and machine tooling automated production equipment. Security. It is widely used in security devices such as security and surveillance cameras. Applications in medical. Stepper motors are used inside medical scanners, samplers, and also found inside digital dental photography, fluid pumps, respirators, and blood analysis machine. Consumer electronics. They are used in consumer electronics in image scanners, photocopiers, and printing machines, and in digital camera for automatic zoom and focus functions and positions. Aerospace and defense. Satellites, ground vehicles, targeting systems, aircraft, ventilation, etc. Conclusion: a stepper motor or a step motor is a brushless synchronous motor which divides a full rotation into a number of steps. Unlike a brushless DC motor which rotates continuously when a fixed DC voltage is applied to it, a stepper motor rotates in discrete step angles. The stepper motor can be controlled with or without feedback. Thank you.